So the way this equation is used most often is we have a sample, like our rainwater or something like that. And we do one standard addition. Standard addition number 1. And then we have a new sample. So, we take, we'll have our IX, we have IS plus X, number 1. We do an additional standard addition. The concentration is increased a little bit more. We'll get a new signal out of that. And then we repeat this process as many times as we are willing to or as is required by our procedure here. And what that will give us is we can then go ahead and make a plot where we have, on our y-axis, we have all the different IS plus X values times VF over V naught. So the V naught will be the same and the VF keeps increasing as we keep going, keep adding more points. And then on the x-axis, we plot what we've defined as x up here, our concentration of standard times Vs over V naught. So again, Vs is going to keep changing as we do this, right? As we add more standard, the amount of standard we've added keeps increasing. And then we'll get a line, ideally, where the slope is equal to our initial signal divided by xi. And the intercept here will be ix. Right, that's what's defined in our equation up here. Now, if we go ahead and solve this and find the x-intercept, that's going to be equal to negative xi. And that's just due to this relationship between m and b. The fact that there's an ix in both of them, things will cancel out, and we'll get that this is equal to negative xi. So this is how we set up a standard addition situation like this. And we'll actually get the chance to do this semester, maybe online. I haven't decided how we're doing all the labs exactly. But one of the experiments we'll be doing will involve a standard addition, and we'll be doing measurements with the ion selective electrode, and you'll be able to use this equation for that standard addition process. In the next video, we'll look at a slightly different way of doing standard addition that has a somewhat similar but different equation where we keep the volume constant across all of our standards.